Muhammad Arfian bin Ismail from Universiti Malaysia, Pahang, Al-Sultan Abdullah, Malaysia. He is an associate professor at the Faculty of Computing and a key member of the Machine Intelligence Research Group, or MIRG. His expertise lies in soft computing, machine learning, 5G system, and methodistic algorithm, with extensive research in optimization and artificial intelligence. Dr. Arfian has significantly contributed to the field of methodistic algorithm, which are widely used in solving complex optimization problems in industries such as engineering, finance, logistics, healthcare, and computer science. He also been actively involved in advancing research on swarm intelligence, evolutionary algorithm, and human-based optimization technique, making him a leading researcher in AI-driven optimization solution. Okay, today, Dr. Arfian will deliver his keynote speech on methodistic algorithm, current trend, and application. This session will provide in-depth exploration of
Recording in progress.
Methodistic technique are transforming optimization strategies in real-world application. And through this presentation, Dr. Arfian will highlight how evolutionary computation, swarm intelligence, and physics-inspired optimization method are shaping the future of AI-driven decision-making. Without further ado, please join me in welcoming Associate Professor Dr. Muhammad Arfian bin Ismail. The screen is yours.
Okay. Assalamualaikum and good afternoon all. Can you hear my voice?
Yes, briefly clear, Dr. Arfian.
Okay. Can I? So who will share screen, me or Dr. Hanif?
Maybe from this operator will, or up to you, Dr. Arfian. You prefer?
Because I have update my slides. Can I can I share my screen?
Okay, please to the operator, Dr. Arfian will share from his own PC. Okay.
Okay. Okay. Okay, so can you see my screen?
Yes, we have clearly seen your screen, Dr. Arfian.
Okay. Okay.
30 minutes to presentation and 20 minutes to discuss.
Okay, I hope I can manage to end my slides lah.
Okay.
Okay. First of all, thank you to the organizer, to Dr. Hanif, for inviting me to give my speech on the meta-heuristic algorithm, current trends and application. Okay, moving on to the next slides. Okay, so this is me. I believe Dr. Hanif have introduced me. Okay, my name is Muhammad Arfian bin Ismail. Currently, I am an associate professor at Faculty of Computing, Universiti Malaysia Pahang, Al-Sultan Abdullah in Malaysia. Okay, let's go to the slides lah. Okay, before we what we call it, we move on, we go further. Let's take a look on the what we call it, the definition of meta-heuristic algorithm. Okay, I believe some of you know the meta-heuristic algorithm, and some of you didn't know what is the meta-heuristic algorithm. Okay, meta-heuristic algorithm is the combination of the word meta, which means beyond, and then heuristic. The meaning of the heuristic is search. So these two word actually came from the Greek words, Greek word, and then this word meta-heuristic was what we call it, was introduced by Glover in 1986. Okay, in the computer science and mathematical optimization, meta-heuristic was defined as a high-level procedure or scientific activity where we used to find or we use to generate and learn the heuristic method for problem solving and discovery. Okay, a meta-heuristic algorithm is an algorithm where it's designed to solve many problems which came from the hard optimization problem without we know the deeply of that problem lah, because normally meta heuristic will learn the problem by itself. Okay, meta heuristic are generally applied to the problem for which there is no satisfactory problem specific algorithm to solve them. Okay, so which mean we use meta heuristic to solve the problem that cannot be solved, that had to be solved by the mathematical algorithm. Okay. The goal of a meta heuristic is to explore the search space to find the near optimal solution efficiently. Okay. The goal this search the second point, the search strategy is to model the mechanism behind an inspiration like a swarm of ants, where we use the ants to represent the solution. Okay, defining a meta heuristic around a search strategy require us to pursue scientific and engineering goals. The scientific goal is to model the mechanism behind an inspiration like swarm of ants. The engineering goal is to design system that can solve practical problem. Okay, while it's impractical to define a generic framework where we can discuss some defining characteristic. Okay, and then in the operation of meta heuristic, normally it involve the balance between exploration and exploitation. This is the one of the key aspect of any meta heuristic approach, where it is to strike the right balance between exploration and exploitation. The objective of exploration is to explore as much as feasible region as possible to evaluate suboptimal solution. Meanwhile, the objective of exploitation is to explore the neighborhood of a promising region to find the optimal solution. Okay, employing a fitness function to evaluate the candidate solution is a must in meta heuristic. Okay, um, almost in all such meta heuristic, we tend to use a fitness function to evaluate the candidate solution, to evaluate the solution that we generate from the process lah. Okay, this is to sample the best solution so far in order to focus on exploitation. Further, we use a certain aspect of the strategy of search strategy to bring randomness and emphasize exploration. This is unique to every search strategy and hence quite difficult to represent using a general formulation. Okay, so this is the normal, the what we call it, the normal operation in meta heuristic algorithm. Normally, it's it is it start with a generate initial solution. Okay, after we generate the initial solution, the first solution, we need to evaluate the solution whether the solution is meet the n criteria or not. Okay, if the solution is meet the criteria, the one that we want, so the what we call it, the process is terminate lah. So the algorithm is come to the end. Okay, if the candidate solution that we generate is not satisfied, we didn't satisfy the solution, we didn't satisfy the solution, we need to employ specific search strategy where we need to modify the solution. It depends on the on the type of meta algorithm. So this is the iterative procedure. So continue again. It will continue again where we need to evaluate the solution before we decide whether the solution is meet our criteria or not. Okay, so this is the what we call it, the general process of the meta heuristic algorithm. Okay, so before we go further, you need to know the characteristic of meta-heuristic algorithm. Normally, meta-heuristic algorithm, they are nature inspired, whether by the evolutionary or by swarm intelligence. And some of them based on metapora base. Okay, normally based on some principle of physics, biology, or ethology. Okay, so based on this metaphor, based on this empire, we can create our algorithm. Okay, normally meta-heuristic algorithm make use of stochastic component where it involve the random factor lah, because we didn't know the problem itself. So that's why at the beginning we need to involve the random. After that, our algorithm will learn the problem by itself. And then the third point, normally meta-heuristic algorithm have several parameters that need to be fit to the problem. So this is the common characteristic of a meta-heuristic. It depends on the type of the algorithm lah. So in the GA we have population, we have crossover, mutation, something like that. For the particle swarm optimization, we have different type of the operator lah, of the parameter. Normally, meta-heuristic is very simple and easy to be used, to be implemented. And then meta-heuristic are problem independent, and they do not require specific knowledge lah. So because meta-heuristic will learn by itself. And then they may utilize their search experience to guide the search. That's mean meta-heuristic have can learn the process to the our solution lah. So this is the what we call it the common characteristic of meta-heuristic algorithm. Okay, and then this is the common term in meta-heuristic algorithm. Okay, so this is the common words that we use in meta-heuristic algorithm. Okay, the first one is the exploration. Okay, exploration. This is the process of exhaustively searching the solution space to find the promising area. And then the search space is quite wide lah. Okay, an algorithm may not locate the area containing the global optimum if it does not have good exploration capability. Normally, exploration involve global. So global, that's mean wide lah. And then normally, exploration can start in the global optimum where it cannot move forward, where it cannot find the good solution. Meanwhile, for the exploration, okay, the exploration means that the process of searching in a promising region to find the best solution. Normally, an algorithm may not be able to find the optimum of the promising region without this capability. Okay, normally exploitation it find their neighbor not so far, the range not so wide as the exploration. So exploitation is neighborhood, the what we call it, near to the solution lah. Normally, for the exploitation, we have problem like stuck in local optima. Okay, exploration for the global, exploitation for the local lah. Okay, and then another terms that we normally use in meta-heuristic algorithm is convergent. Okay, convergent means that the state when the characteristic of all solution of a population-based meta-heuristic become similar, and the solution is not improved. So we can view the convergent in graph. Normally we view in the graph lah. It will start at a value. It cannot move forward. It cannot go to the another solution. Okay, if lacking this ability, an algorithm may not be able to exploit the promising region well. Okay, and then premature convergence. Normally, it related to the convergence lah. Okay, premeditated convergence avoidance. Okay, how we want to avoid the premature converge. Okay, premature converge is the state that occur when the whole population converge to the some local optima in early iteration. This usually happens when the algorithm cannot escape local optima due to having an unbalanced ratio of exploration and exploitation. Normally, premature because of the uh, cannot balance lah between exploration and exploitation. And then another terms that that we normally use in meta-heuristic algorithm is convergence speed. It is how quickly the characteristic of all solution becomes similar is called the convergence speed of the algorithm. Okay, a reasonable algorithm is supposed to have a good convergence speed that prevents premature convergence. However, it allows the most promising area to be exploited to reach the exact global optimum. So this is the common term in the meta-heuristic algorithm. Okay, a meta-heuristic algorithm will be successfully on a given optimization on the problem if it can provide a balance between the exploration and the exploitation. So in meta-heuristic algorithm, normally we want to balance between exploration and exploitation, where we don't want our algorithm to become stuck in the local optima or stuck in the global optimum. Okay. Okay. This is my from my research lah, from my personal perspective. Okay. Normally, what we have, what I and my team have observed, we can classify the meta heuristic into two types lah, which are single solution based meta heuristic, and another one is population based meta heuristic. Okay, normally for the single solution based meta heuristic are more exploitation, while population base is more on the exploration. Normally single, it only involve only one solution lah, and then population in more than one. Okay, so let's take a look on the um, single solution. Okay, normally we know that as trajectory methods. Okay, for the single solution, it start with a initial solution and move away from it. Normally on the single, it just looking at the neighbor. Okay, some of them can be seen as intelligent extension of a local search algorithm. Okay, example of the single solution based methodology. Example is simulated annealing method. Okay. The second one is type search. The next is the GRASP method, and the last one is variable neighborhood search. Okay, this is the just the example. Actually, there are a lot. So this is the example where I found that this is the commonly used in the engineering domain. Okay. Okay, so this is for the simulated annealing. Okay, the first one of the single population base. Okay, this is the quite famous in this type. Okay, simulated annealing proposed by Kirkpatrick and his team. Okay, sim SA, I call it SA lah. Is inspired by annealing technique used by the metallurgists to obtain a well-ordered solid state of minimal energy. So it based on the it's inspired on the physics lah. Okay, this technique consists in carrying a material at high temperature, then in lowering this temperature slowly. So this is the first algorithm under single population base. So another one, another famous one in under single population is tabu search, or we call it as a TS, tabu search. Tabu search was introduced by Glover in 1986. Okay, Tabu search was designed to manage an embedded local search algorithm. It explicitly used the history of the search both to escape from local minima and to implement an explorative strategy. Okay, its main characteristic is indeed based on the use of mechanism were inspired by human memory. It takes from this point of view a path opposite to a path opposite to that of essay, which does not use memory and thus is unable to learn from the past. Okay, various type of memory structure are commonly used to remember specific properties of the trajectory through the search space that the algorithm has undertaken. So this is a tabu search. Another type of the single population base is GRASP method. Okay, GRASP method stand for greedy randomized adaptive search procedure, where it is a memory-less multi-step meta-heuristic for combinatorial optimization problem. Okay, it proposed by Few and Resende. Okay, okay, in the process of GRASP, each iteration of GRASP algorithm consists of two steps, which are construction and local search. The construction step of GRASP is similar to the semi-greedy heuristic, where it builds a feasible solution using a randomized greedy heuristic. Okay, and then for the next step, for the second step, this solution is used as initial solution of a local search procedure. Okay, after a given number of iteration, the GRASP algorithm terminates and the best solution is found. Okay, so this is GRASP method. And then another one under the single population base is variable neighborhood search, were proposed by Hansen and Maldenovic. Okay, it is based on strategy consists in the exploration of dynamically changing neighborhood for a given solution. Okay, at the initialization step, a set of neighborhood structure has to be defined. This neighborhood can be arbitrarily chosen, but often a sequence of neighborhood with increasing cardinality is defined. Okay, in principle, they could be include one in the other. Okay, VNS, variable neighborhood search, consists of three steps, which are shaking, local search, and move. So this is the general step that involved in the VNS. Okay, so now we move on to the population solution based meta heuristic. Okay, normally uh, population based meta heuristic deal with a set of solutions. So it can be have more than one solution lah. Okay, the most or the early study population based method are related to evolutionary computation and swarm intelligence. Okay, evolutionary computation algorithms are inspired by Darwin evolutionary theory, where a population of individuals is modified through recombination and mutation operator. Meanwhile, swarm intelligence, the idea is to produce a computational intelligence by exploiting simple analogy of social interaction rather than purely in individual cognitive ability. Okay, but what we can see, what I and my team see, we can classify, we can categorize the population base into four category lah, which are evolutionary algorithm, swarm intelligence, physics-based algorithm, and human-based algorithm. Okay, so so as you can see from the screen, evolutionary based method. So this is based on the natural, inspired based on the natural evolution lah. Okay, normally they based on the survival of the fitness, reproduction, and mutation. Okay, in EA, we create a population by using the selection and then crossover and mutation. Example of the EA are genetic algorithm GA and differential evolution DE. So this is the actually there are a lot, but this is the two famous method lah. Okay, so I believe no need for me to explain in detail lah about the GA. So because you can distribute my slide to the audience later. Okay, so this is the differential evolution algorithm. Actually, they are similar. For the GA, it uh, we create the net solution, the child, by using crossover. But different with differential evolution algorithm, we create the child by using the mutation operator. So different. That's the different. Okay. So now we move on to the next category, which is a swarm-based method. Okay, swarm intelligence is a branch of artificial intelligence that is inspired by the behavior of social animals such as ants, bee, or birds. Okay, it refers to the collective behavior of a decentralized, self-organized system where individual agents interact with each other and with their movement to achieve a common goal. Okay, so example of the swarm based method are particle swarm optimization (PXO), and then another one is ant colony optimization. So this is the pioneer for the swarm based method, and then this algorithm is widely used. Okay, widely used. Okay, so this is the detail. So no need for me to explain in detail lah. And then another type for the meta-heuristic algorithm is human-based method. Okay, human-based meta-heuristic algorithm are a class of optimization technique that incorporate human intelligence, knowledge, and experience into the optimization process. Okay, by incorporating human intelligence, knowledge, and experience into the optimization process, this algorithm can often find high-quality solution more quickly and efficient than traditional optimization technique. Okay, the example that fall under human-based method are imperialist competitive algorithm and teaching learning-based optimization. Okay, so this is the two earliest method under the human-based method. Okay, imperialist competitive algorithm and then teaching learning-based optimization algorithm. So this is just the example lah. And then the last what we call it, the last part that fall under population based is physics based method. Normally, these algorithm are class of mathematical algorithm that are inspired by physical law and principle. Okay, this algorithm use a concept from physics such as energy and force to guide the search for optimal solution in a problem space. Example is gravitational search algorithm and then electromagnetic field optimization. So this is the example of the physics-based algorithm. Okay. So meta-heuristic algorithm have several advantages and disadvantages, where normally it depends on the problem that we are going to solve lah. Okay, in selecting the suitable meta-heuristic algorithm, there are many factors that need to take into account. Okay, so this is the common advantage and disadvantage. Okay, okay. Normally, what makes that this algorithm become good or not, because there are so many factors lah, such as number of population, and then such as the parameter that involved in the algorithm. Okay, the specific parameter according to the algorithm itself, like the process involved in the algorithm? How many parameter that that need to be used? And then if involve many parameter, what about the speed? Of course, it will have effect on the performance. And then is the algorithm is easy to use or not? Okay, so this is the problem that related to the parameter. And then this is the what we call it, the the normal that we facing in when we use meta algorithm is start in optima, which is local and global. So this is the common problem that we face. Okay, so this is the advantages. So advantages of the meta algorithm. Okay, the first one is as you can read from the slide lah. Meta-heuristic algorithms are designed to handle complex optimization problem that cannot be solved by traditional optimization methods. They can search large solution space and find good solution that may not be found by other methods. And then the second advantage, is meta-heuristic algorithm do not require the objective function to be differentiable, which make them suitable for nonlinear and uh, non-differentiable optimization problem. Okay, and then meta-heuristic algorithm also can be paralyzed. So which mean that we can meta-heuristic algorithm can be easily parallelized, which allow them to modern parallel computing. So by using the parallelization, um, the meta-heuristic algorithm are generally robust to noise and uncertainty in the optimization problem. They can handle the heuristic algorithm. It will learn during the iteration. Most meta-heuristic algorithm have straightforward implementation step and do not require extensive mathematical formulation. So we can say that it's easy, simple in implement the algorithm. Okay. Okay. Beside there are lack lah. There are not guaranteed to find the optimal solution to an optimization problem. They may find a good solution, but not the best possible solution. Beside that, if we want to use meta algorithm, but actually it depends on the problem lah. Meta heuristic algorithm can be computationally expensive, especially for large scale optimization problem. They may require a large number of function evaluation to find the good solution. Okay. Beside that, parameter sensitive. Okay. Tuning parameter, which is sensitive. The parameter is sensitive. Meta-heuristic algorithm has several parameters that need to be tuned to achieve good performance. Finding the optimal value for this parameter can be a difficult. Forming performance depends on the tuning of algorithm parameter, such as population size, or mutation rate, or learning factor. Okay. Beside that, meta-heuristic is a black box approach, which means that meta-heuristic algorithm do not provide insight into the underlying structure of the optimization problem. It cannot give. Okay, they are a black box approach. Okay, that search for good solution without providing information on how the solution were found. So this is the advantage of the meta algorithm lah. And then lastly, second last specific tuning. Okay, actually different type require different parameter. Okay, different problem also require customized adaptation of meta-heuristic strategies, which making generalization challenging. Okay, and then um, meta-heuristic also involve the random factor, where due to the random in search process, different algorithm may produce different result. Okay, where it requiring multiple execution to validate the solution. Okay, so this is the disadvantage of the meta heuristic algorithm. Okay, so in conclusion, meta-heuristic algorithm has several advantages and disadvantages. Okay, and the choice of algorithm depends on the characteristic of the optimization problem and the available computing resource. Meta-heuristic algorithm can provide an effective tools for solving complex optimization problem, but their limitation should be considered lah. Okay, so this is the several common case that we can use the meta algorithm, such as we can use in the engineering sector or finance, logistic, healthcare, computer science. Actually, there are a lot. So this is the just the example. Okay, so this part just the example of the domain. Okay, what I want to share to you. Okay, before that, let's take a look on the historical overview of the meta heuristic algorithm. How the meta heuristic evolve. Okay, normally it start in 1953, where this is the first starting point of the meta heuristic algorithm lah, where simple algorithm was developed by George Danzig, we known as the linear programming, and then in the year 1975, so this is the starting point of the meta algorithm, which is genetic algorithm, was first introduced by John Helen, and then 1983 simulated annealing is introduced by Kirkpatrick, Gellert, and Vecchi. And then in the 1990s, this is the rise of swarm intelligence based algorithm, where the first one is developed uh, AC, N colony optimization by Marco Darigo. And then in 1995, particle swarm optimization was introduced by Kennedy and Bahad. And then in 2000, this is the emerging of new generation of meta-heuristic algorithm, where it inspired by nature and human, such as artificial bee colony, firefly algorithm, gravitational search algorithm, and teaching learning based optimization algorithm. Actually, there are a lot. And then in 2010, this is the advance in hybrid and physics inspired meta heuristic, where in this year we have gray wolf optimization, Harris optimization, and many lah. So this is what I found lah in my research. So this is the overview of historical of meta heuristic algorithm, how the meta heuristic evolve from year to year. Okay, now let's move on the current issue of meta heuristic algorithm lah. Okay, so this is the issue that we need to consider in using meta heuristic algorithm. Okay, um, so the first one is no theoretical converge guarantee. Okay, meta heuristic do not guarantee finding the global optimal solution. Because they are really on rely on probabilistic approach. Okay, many algorithms stop when a predefined number of iteration is reached, not when an optimal solution is found. Okay, so in order to tackle this problem, this is the possible solution lah, but I didn't know. I didn't test yet. Okay, maybe you can test lah after this. Okay, normally we can use a convergence analysis technique or hybrid method in order to solve this problem lah, this issue. Okay, and then the second issue that I can see is the premature converge and local optima. Okay, normally algorithm may get stuck in local optima, especially in complex multimodal search space. Okay, for example, in genetic algorithm, if diversity is lost too early, the population may converge to the suboptimal solution. It has a premature converge. It converge too earlier. Okay, so in order to tackle this problem, we can use the adaptive mutation or crossover strategy in order to maintain the diversity of the solution. Or we can also hybrid with local search method, like you can hybrid genetic algorithm with simulated annealing. Okay, or you can use the chaos theory based or quantum inspired algorithm for better exploration. So this part is not so new, but you can try to research on this lah. So this is the possible solution. And then the issue of the next issue of the meta heuristic algorithm is parameter sensitivity and lack of generalization. Okay, which means that the performance is highly sensitive to parameter setting. Okay, because different algorithm have different parameter lah, such as in GA it involve um, selection, also involve mutation, it also involve crossover. So three parameter. So different algorithm involve different parameter lah, and then the number of parameter depends on the algorithm itself. Okay. A well-tuned algorithm for one problem may perform poorly on another. So if we use that setting on this problem, on the different problem, maybe the setting may be different lah. Okay. In order to what we call it to overcome this problem, we can also use a self-adaptive algorithm or meta learning approach. Okay. And then the next issue on the meta algorithm is high computational cost for large scale problem, where it require a large number of functions evaluation, and that it will make the speed of the algorithm become slow lah. Okay. So solution, you can use the parallel computing. Okay.
Sorry, Dr. Arfian, because
Yes.
the time is up, please kindly prepare to conclude your remarks. Thank you for your insight.
Okay. So this is the um okay. So my conclusion is okay. Several issues have arisen due to the many novel meta-heuristic algorithm, because as we can see that there are a lot uh, what we call it, new algorithm that propose, but um the last point useless metaphor. And then the current algorithm is lack of novelty, and then poor experimental validation and comparison. So if you notice that currently there are a lot of algorithm being introduced, but the performance same. Okay, the performance is same. Rather than you introduce new algorithm, try to improve the algorithm itself. Okay, so no need to introduce the new algorithm. Try to improve the algorithm itself. Okay, I think that's it from me. Okay, thank you. Pass back to Dr. Hanif.
Okay, thank you, Dr. Arfian. Ladies and gentlemen, we have just had the privilege of listening to an insightful keynote presentation by Dr. Arfian bin Ismail on methodistic algorithm, current trend, and application. Now we will move to our discussion and question and answer session. we have maybe for one or question where you have the opportunity to engage directly with Dr. Arfian and explore the insight from his presentation. This is your chance to ask question, seek deeper classification to discuss the real world application of methodistic algorithm and AI-driven optimization technique. Let's begin to discussion. Who would like to ask the first question? Maybe from participant or maybe from chat before we move to the second keynote speaker. Okay. Any question from the participants? Okay. If there are not question from participant, maybe I have one question, Dr. Arfian bin Ismail, for in your presentation among the different type of methodistic. For example, you have explained about evolutionary base, swim intelligent, human base, and physics base. Which do you think has the most potential for future breakthrough? What are the biggest challenges in design and efficient methodistic algorithm for real world application?
Okay,
Maybe
I
our
said in the presentation, actually it depends on the problem itself.
hmm.
So maybe sometimes a genetic algorithm is good for health, and then maybe sometimes particle swarm optimization is good for finance. It depends on the problem itself actually. So there are no algorithm that work good on all the problem. Mhm.
Hmm. Okay, thank you, Dr. Alfian, for your insightful discussion. Maybe another question from the participant. Okay, okay. Because of time, thank you, Dr.
Okay.
Alfian bin Ismail, for your insightful presentation. We now we going to the next presenter. It's with great pleasure that I introduce our fourth keynote speaker today, Mr. uh, Daniel from Tecme Engineering. Mr. Daniel is a prominent figure in technology and engineering sectors, known for his extensive expertise in specific area of expertise, for example, software development, data analysis, and etc. He has been instrumental in leading innovative project at Team Engineering, contributing significantly to advancement scientific, for example, in artificial intelligence and machine learning. Throughout his career, Mr. Daniel has demonstrated a commitment to excellence and innovation, leading to award or recognition. His work has not only advanced the capability of STEM engineering, but has also had profound impact on the broader industry. Today, Mr. Daniel will share his insight on presentation about the lack of regulation about a common standard protocol for asset management in the healthcare industry. Without further ado, please join with me welcoming Daniel from Tecme Engineering. Daniel, the screen is yours.
Thank you very much, Doctor, for the introduction. Can you hear me well?
Yes, you're
Okay.
That's very clear.
Okay. Okay. So once again, thank you very much for the introduction. Well, first of all, thanks to the Dr. Sinung Suakanto for allowing me to participate in this conference. Secondly, about me, I'm degree in information system engineering in Argentina. Nowadays, I'm an international sales manager for a multinational medical device company. I'm here as an individual, not representing any private corporation. as you mentioned, based on my experience in the IT and telecommunications industry and now in the healthcare industry. And well, again, I have worked in the IT and telecommunication industry for almost 20 years, and from the last 11 years working in the healthcare industry. Finally, I'm going to share a very short presentation as an introduction of the issue in the healthcare industry in order to see if data science could help somehow. This presentation is not a research. It's not a research at all. It is based on my previous experience and the current one. So, well, the lack of the topic of this presentation is the lack of a regulation about the common standard protocol for asset management in the healthcare industry. What is the agenda? What is the current status of the asset management in the healthcare industry? Why is necessary to do something about this lack? And what is necessary to do? Next, please. Yeah. What is the current status of asset management in the healthcare industry? Well, the problem is that there is not a common protocol for monitoring and for the management of the assets in the medical institution, publics or privates. This is a problem when the medical institution, the hospitals, want to monitorize or to manage their assets. Why? Because in case of the medical institution wants to manage its own assets, the only way to do it is by integrating, customizing each vendor medical device that they want to be under management. It will be costly due to the manual customization. It will take time due to the integration might be through a manual developing for each vendor to be under the platform for the asset administration. Another issue is that probably not all the medical devices have a protocol, since there is not a regulation about it. There is not a regulation to obligate to each vendor in the world to have a standard protocol for management on the medical devices. Another potential inconvenience is that in future, in case the same medical institution already with the previous customization for the medical devices would like to implement or to add another vendor into the ecosystem, well, then once again, another manual customization has to be done. And once again, it will be costly, it will take time, etc., etc., etc. Next, please. Well, why is necessary to do something about the lack of a common standard protocol in the healthcare industry? Because every time that a medical institution would like to begin to administrate proactively the medical devices, a manual integration has to be run. It is costly. It has to be a custom integration due to the lack of a standard protocol. It will take more time in comparison if there could be a standard protocol. We could say manual integration versus plug and play integration. Well, since there is not a regulation to obligate to medical device manufacturers to include a standard protocol in their devices, not all medical devices are released at least with the protocol for management. It means that some medical devices are released with its own protocol, but it is not a standard protocol. Some medical devices are released without any kind of protocol for management. It will depend on the company. If the medical device company or healthcare company or pharmaceutical company with the devices that they release, they want to include a protocol, okay. But if they don't want to include the protocol, okay too, because there is an obligation. In summary, since there is not a standard protocol for asset management in an ecosystem of different manufacturers, the disadvantages are a lot, and the advantages will be a lot too. Next, please. Okay, this is a picture of the integration data in the healthcare industry. Okay, it's just a picture to show how the hospital could be handled. Okay, the medical devices that they have, or the patients, etc., by integrating all the information under a management software, but always running a standard protocol. Next, please. Well, finally, what is necessary to do? First, to create conscience about the necessity to have a regulation for having a standard protocol in healthcare industry. This is the first, to create the conscience, to understand that the healthcare industry do need a standard protocol. Second, to confirm a regulation in order to each vendor, each manufacturer in the industry includes the common protocol in their devices. Third, to develop a common standard protocol, perhaps something similar to SNMP protocol. SNMP is the standard protocol used in the IT and telecommunication industry. Very simple, very effective. At the same time, if this happens, a new industry will born. There will be software companies creating administration platform for the asset management in the healthcare industry. There will be companies offering value-added services for the asset management at medical institutions, 24/7 services, doing real-time monitoring for data analysis. Some examples: data analysis, performance reports, activity, etc. Monitoring in real time to be proactive for avoiding potential failures on the devices, consequently, potential interruption of functionality, proactive maintenance services, delivery of remote maintenance services, thousands of variables on each medical devices to be monitored and analyzed. Therefore, better decision will come for better training to the patient. So the question is, could the data science collaborate for solving the problem of the lack of regulation about standard protocol for the asset management in the healthcare industry? So this is all, I think. Next, please. Well, this is the last slide to show all the industries we have under the umbrella of the healthcare industry: medical imaging, well, drug, healthcare, pharma, patients, etc. There are a lot of different verticals under the umbrella of the healthcare industry. But once again, there is no a common standard protocol in the industry. There is no a regulation. So I think that this is all. Next, please. Thank you.
Okay. Thank you, Mr. Daniel, for your excellent presentation. Okay, ladies and gentlemen, esteemed participants, we have just had the privilege of listening to an insightful keynote presentation by Mr. Daniel from Tecme Engineering. on the lack of a regulation about a common standard protocol for asset management in the healthcare industry. His presentation has provided us with valuable insight into the challenges of medical device integration, the necessity of standards protocol, and the impact of data-driven healthcare asset management. Okay, now we open the floor for our discussion and question and answer session, where you have the opportunity to engage directly with Mr. Daniel. I think this is a great chance to ask a question, seek deeper insight, or discuss possible solution and implementation regarding healthcare asset management and regulatory framework. Okay, let's begin to the discussion. Who would like to ask the first question? Okay, please, from the participant, maybe one of you can give some question to Mr. Daniel about the lack of regulation about a common standard protocol for asset management in the healthcare industry. If you have question, kindly raise your hand or type it in the chat if you are joining online. Okay, maybe any question? Mr. Sinu, do you have a question for Mr. Daniel?
Yeah, I think I'm not giving a question, but maybe I agree with the presentation of Mr. Daniel. So I think the protocol standard in healthcare must be created with the common protocol. So I think it's important because we can see that every devices or every healthcare asset currently has maybe some sensor, or maybe they have mechanism to send the data into the cloud. So whenever each vendor must be sent with own protocol or maybe with own their format of the data, it is very difficult to create the same dashboard or create the same system for that. Okay, maybe that's my opinion. Maybe how about you, Mr. Daniel? About my opinion?
Yes, absolutely agree with your opinion. Yes, nowadays there are companies again that has their own protocol, okay, but there is no common language. So there is a problem when you want to integrate. It is possible to integrate, but you have to do it manually. It will be costly, and I'm seeing this problem every day in the industry. Yeah. So yeah. In the end, well, it is a problem for the medical institution, and in the end, it is a problem for the end user, the patient.
Yes, maybe I give the next, not next question, but next discussion. How about we want to bring our dislike of the common protocol to the vendor, and they can aware about it, and so most the vendor of healthcare, they must maybe must create some forum, and they can decide some the same protocol and the same maybe the data format, or maybe the same I think maybe for example creating blockchain for healthcare, so every vendor, every hospital can be share each other. Okay, that's in my
Yes.
opinion.
Yes. Create a forum and create a campaign, no, to create conscience about the issue.
Okay, thank you, Dr. Daniel and Dr. Sinung for your exciting discussion. We still have time for a few more questions. Please feel free to share your talk or inquiry. Maybe another question from the participant to Mr. Daniel. Okay, because there is no question, it's my job to ask you Dr. Mr. Daniel Korenblum. I have some questions because it's the challenges topic in our country in Indonesia about healthcare asset management. In your presentation, you highlight the challenges of medical device integration. What are the most critical consequences of not having a standardized asset management protocol in healthcare institutions? And then what are the biggest barrier preventing the adoption of a common standard protocol in the healthcare in this industry? And the last, how do difference between public and private medical institution affect their approach to the healthcare asset management? Maybe you can give some suggestion to our country to improvement the healthcare asset management. Okay, what you talk, Mr.
Okay,
Daniel?
I think that you made three questions in one, but I have in mind. Well, I will begin for the last one. Private and publics have the same problem. Okay, have the same problem. The only difference is the owner is the government in public, and in the private is an individual or group of individuals. So they are both private and public are suffering or having the same problem. Then you mentioned something about the barrier, okay,
Yeah,
for
the barrier.
having a, well, I think that it shouldn't be a barrier. It shouldn't be a barrier at all. I think that during the last, once again, I'm in this industry from the last almost 12 years, okay? And year after year, I'm realizing that the vendors, the manufacturers are creating their own software management, okay? The platform for the management of their own devices, okay? Okay, let's suppose company manufacturer A. Okay, all the devices that the manufacturer A have, all those devices will be uh, will be managed, okay, by the software that the company A has developed. Okay, then we have the manufacturer B or C. Same thing. Okay, the manufacturers are creating their own software for handling their own devices. Okay, but in the reality, in the life, the hospital, it doesn't matter the country, there will be an ecosystem of different vendors. So there is when the barrier, the problem come, the critical issue. Okay, the first question you made, doctor. Okay, let's suppose I am the director of this hospital in Italy, in Argentina, in Indonesia, in the United States. Okay, but I have an ecosystem of different vendors. Okay, so me, as the director of the hospital, I would like to do monitoring, okay, in real time, to see statistics, trends, okay, to take proactivity actions, okay, before a failure, or to analyze the information, okay, that the device could give me for providing better treatment, okay? Some of the examples, like me as the director of the hospital, would like to provide to my patients. Okay, but now the problem. I have vendor number one, vendor number two, vendor number three. Okay, what I will do? I have to hire a company. Actually, there are companies in the world nowadays providing software for management. But what these private companies do? They sell the software, but they have to integrate vendor A, vendor B, vendor C. Okay, my problem is solved. In a year, I will buy a device for company 4, company D. So now I have to call again to the company that sold the software, and they have to come back to integrate vendor 4. Let's suppose that in a year there is a new device, okay? So all the integration has to be manually, okay? Because there is not a standard protocol. What I saw in the IT and telecommunication industry, that there was a common protocol. So every device that you was released to the world was under SNMP protocol. So there is no problem, okay? For me, as the director, there will be a simple integration because all the devices comes with one protocol that the platform could understand easily. All of the vendor speak the same language. So this is the problem that the healthcare industry has nowadays.
Okay. Thank you for your insightful discussion, Mr. Daniel. A special appreciation goes to Mr. Daniel for sharing his expertise on the future of healthcare asset and management and the role of technology in driving efficiency and regulatory improvement. Thank you, Mr. Daniel. We now move forward to next session. Let's give a big round of applause to Mr. Daniel from Tecme Engineering. Thank you, Mr. Daniel, for your insightful presentation. Now, ladies and gentlemen, distinguished guests and esteemed participants, it's my pleasure to introduce our fifth keynote speaker today, Mr. Mahalingam. Sorry if my pronunciation is wrong, Mr. Raj, a data scientist at Intel and expert in applying design thinking in data science and information systems. Mr. Raj Mahalingam is an experienced data science at Intel, specializing in machine learning, supply chain optimization, and data-driven decision making. With a strong background in AI, analytics, and business intelligence, he has contributed to numerous high-impact projects in semiconductor manufacturing, pharmaceutical, supply chain management, and industrial data analytics. Mr. Raj's expertise lies in integrating design thinking into data science, focusing on human-centered interactive and solution-driven approach to problem solving. He has worked on optimizing supply chain disruption, semiconductor material demand forecasting, and customer-centric AI solutions. His approach combined data analytic, business intelligence, and visualization technique to bridge the gap between technical problem solving and business impact. Okay, today in this conference, Mr. Raj Mahalingam will deliver his keynote speech on design thinking, a human-centered approach to data science and information system. In this session, he will discuss how design thinking principle can transform data-driven strategies, make them more user-focused, practical, and effective. Okay, with the increasing role of AI and big data in business and industry, Mr. Raj's insight will be invaluable in understanding how to find raw data into actionable intelligence through design thinking. Without further ado, please join me in welcoming Mr. Raj Mahalingam from Intel.
Hi, good afternoon, everyone. Can you hear me okay?
Okay, I can hear you, Mr. Raj.
Yeah. You also sharing my screen? Okay, perfect. Okay,
we
great.
can see your sharing presentation.
Yeah, it's great to be here with everyone, and I know this presentation will be a little different from others because I am speaking as a connection between the research field and the industry and how data science is getting perceived in the industry and how it has evolved over time. Before that, I want to start with a short story. We imagine there is a lot of intelligent people here, obviously. So imagine a professor who wants to cross the bridge from on a late evening, but the bridge is broken because of some structural issues, and the only way he can go on the other side is go through the boat, and the boat has a fisherman and who can take it to the other side of the shore, and the professor gets in and starts talking about, hey, look at the structure of this bridge, it's broken now. Do you know anything about structural engineering? Do you know about the math and science behind it? And the boatman says, sir, I don't know what it means to be in the structural engineer. And the professor says, oh, poor boatman, you lost 25% of your life. And then they go further, and the professor asks the question, oh, what's the horsepower on your boat? And the boatman says, horsepower? What is it? I have not heard about horsepower. And the professor says, boatman, you lost 50% of your life without knowing what is horsepower. And then they go further, and the professor says, wow, look at the weather is so pleasant, but still you cannot enjoy this. And sometimes it's unpredictable. Do you know anything about weather forecasting? And the boatman says, no, sir, I don't know anything about weather forecasting. And we go further, and the professor says, you wasted 75% of your life. And there is a boom. There's a hole in the boat, and the professor says, what is going on? The fisherman says, like, oh, we have a hole in the boat. We have to jump and swim to the shore. And the fisherman asks, do you know how to swim? And the professor says, I don't know how to swim. And the fisherman says, you lost 100% of your life. So that's how the field of data science has evolved over time. It's just a short story that there is a lot of disconnect between what's happening in the research field and what's going on in the industry, how it perceives it. My idea is not to create a negative perception around it, but rather want to create visibility to what is, how can we bridge these gaps. So next slide. Yeah, so in 2012, I read this article in HBR, which says data science is going to be the sexiest job of 21st century. And at that time, I was about to enroll to my graduate program, and there was only a handful of universities which offered that specialization. But today, if you look at in the US as well as outside, there is a bunch of university that actually offers it. So when you look at the growth of data science, there has been tremendous growth, but the research has grown, but still there is a element of human centered approach plays a big role, and that's what I want to talk about. And how can we create more human-centered approach? And the way to do it is using design thinking. I don't have it. I wanted this to be an interactive session, but since because of lack of time, we have to move forward. How many of you have heard design thinking before? You can raise your hand in the call. Whoever. Or you can paste it in the chat. Whoever is able to access the chat. Okay, assuming that you don't have access to chat, I believe. So let's keep going to the next slides. So design thinking is a human-centered process where it uses its roots from social science research and understanding how humans adapt to change, how the technology can work towards their benefit. So that, can you go to the next slide? Yeah. So it, for the whoever is moderating, I'm gonna send a message on the chat so that we can keep moving to the next slides. So keep an eye on the chat, please. So design thinking is a 5-step process. It is empathizing the problem and understanding, defining the problem, ideating, prototyping, and testing. So this is an iterative approach. It was started as a project from Stanford Business School, Design School, and it has evolved its roots from social science. So that's what we will be talking about, how we can use a human-centric approach of the greatest technology that we can use for the benefit of humans. So next slides. Yeah, so yeah, the same thing. So empathize involves interviews and understanding the customer's base and how to non-judgmentally seek what their business problem is. And ideation involves creating personas. Different people interact with the tool differently. So design thinking actually solves those and hidden patterns that is available within a company. So I work for large pharmaceutical and semiconductor corporations. The greatest technology in data science and tools are very well ended up being not used just because we didn't find a perfect fit in the industry. So as researchers, I think it's important for us to know how it actually get implemented on the application slide. Next slide. Yeah, so what is design thinking? Is it just a tool or is it a mindset? So if you ask me, design thinking is more of a mindset than a tool. So we are trying to understand how design thinking mindset is different from data scientist mindset. So in this graph, in this table, you can see there is a comparison between how empathy plays a big role when we are trying to understand a business problem. Without using the people aspect, we are going to miss out. So understanding that as a typical data scientist, I try to understand the problem through data, but design thinking actually humanizes data and try to understand more on the human-centered approach. And the other thing I want to emphasize, the last point is change management. So like I mentioned, a good enough solution implemented today is better than a perfect solution implemented 3 months from now. So when we look at implementing these data science problems in real world, there is a lot of change involved in the company itself. If it's especially as a large corporations, it has to go through a lot of change management. When you look at just data scientists, we think about improving the model accuracy. How can I reduce the error in the analysis? How can I build a new statistical approach? But design thinking really helps us humanizes that. It's like, yeah, so this is me. I hope it is interactive. So this is Lucy. So this is one of the oldest fossil found in Ethiopia in 1974. This was me. Last week on the celebration of 50 years of discovering Lucy. So Lucy was discovered in Ethiopia, and Lucy was a female, lived around 3.2 million years ago. So the idea here of empathizing is capturing imagination of Lucy. When Lucy lived 3.2 million years ago, what we actually got 50 years ago was just the fossil remains, but we needed to estimate and understand what Lucy's life looked like, what's their behavior, what's important for them, what their eating habits, how did they dwell, did they live in a hut, or did they just were nomadic tribes? So these are the things that comes only with empathizing things. So that's the biggest factor that plays when we try to implement a novel solution that's coming fresh out of research. Next slides. So McKinsey has been estimating there is a new role of called translators. So just like language translators, in this call, we have a lot of folks interacting from different parts of the world. So we needed translators who can translate a business problem to a analytical problem or a data science problem. So it's estimated that there is 5 to 6 million people who will be titled analytics translators, or otherwise data science translators, to build a gap between the academic world and the industry world, how it can be translated. So next slide. So the people who have those skills of translator, they know about the technology as well as the domain that plays a big role. So for them, they are defining the vision behind any data product. So whether it's a problem within supply chain or within marketing, they define the problem. It need not be extensive, so they have to write it down, just like a empirical research. It really helps to write down what the problem is. Need not be a completely vision statement, but at least close enough, and also create personas of people involved in the game. For example, who in the projects I worked on in supply chain industry, there is buyers involved, there is warehouse operations, there's sellers, planners, supply planners. Each of these people play a role. So when I was trying to build a data science model to forecast the demand in future, so I need to work with the stakeholders. For that, I needed to understand their personas to be able to address the opportunities and technological capabilities they already have to make an implement on top of it. Next slide. Yeah. So the third part in design thinking is idea generation. So this is where the core of all the research that has been done, and getting into the point where what is a better fit for this problem. So because of the role of analytic translators is to bring in this gap where they bring in ideas from the academic world to match it with the right problem. So idea generation is one of the key areas where they can promote a very divergent and convergent, where they work upon to come up with multiple ideas. It goes on building, and then they come down to narrow down to the one that is feasible. So when in the world of industry, that they also care about the benefits and efforts. So when they generate ideas, these constraints are taken care, and that is one of the important parts that human-centered design thinking helps. Next slide. So, so ideation on, like I mentioned, we needed to understand the non-functional requirements. Using design thinking really helps navigate the change associated with making that novel machine learning model a reality by making that change for those people involved. Again, going back to the supply chain example, I built the model around summer 2020 for COVID-19 supply disruption. But it took me like another year to implement it because there is a lot of change involved in the buying, supply planning processes they were already doing. So I had to prove how this really works. It doesn't affect what's the risk associated with it, what's the benefits for it. So because I had used design thinking for it, which I will be talking about later, um, it really helps to go ahead of the game. So then it also can address data quality issues. So as you know, in the world of industry, like getting quality data is a problem. So the earlier you know that data quality is a problem, you can prioritize in doing some other project, considering the opportunity cost involved in having bad data. Things like data privacy. So when I was working in pharmaceutical supply chain, there were legal boundaries on personal health information, pricing information. So those are the things that can be revealed in terms of what are the complexities when we use design thinking. Next slide. So yeah, visualization. So obviously people have heard about Tableau, Power BI, ClickView. These are popular visualization tools for visualizing data. Obviously, within Python, as researchers, you might have used R or Python to do data analysis and visualize your data. This design thinking technique also plays a big role in visualizing the problem itself. So you're trying to draw a picture of the process, tell a story, or create a map of all these connecting dots of stakeholders involved in the process. So taking the example of semiconductor supply chain, when I had to work on a problem where supply of a particular chemical is in constraint, and I had to map the journey of this chemical from supplier to transportation team to warehouse, and then to the tool consumption, then it gets recorded in the inventory management system. So how this journey is smoothly followed, what are the lead times between the order time to shipping time to dock time. So all of these are visually represented. So it can promote ideas. It's like. So this is mind mapping is one of the tools that really helps in creating that visual way of what is the problem we are trying to solve. So I know I'm talking in terms of using data science algorithms and research to industry application, but I think the other part of design thinking is it can actually help in the research itself for you to actually bring together ideas, and use such tools can be very, very helpful in even gathering your thoughts from your own research idea. So next slide. Storytelling, obviously, it's a little different from research storytelling. I think both our storytelling makes a powerful impact on it. Research storytelling, I personally have not much exposure to it, but as far as business storytelling, there is a lot more impact of financial elements, benefits, opportunity cost, and understanding the stakeholder needs involved. So like you mentioned, it took me almost a year for me to implement the change of a new forecasting model for the pharma distribution, because the story was not going through. So I had to rebuild that story. My technology was already ready, the techniques was ready, but for me to make the change, I needed to refine the story, and that took time. So when the earlier we use design thinking, it actually makes it better for us to tell a better story. Let's start. So fail fast. So again, this may not be a thing applicable for research. It's fail fast. So we are looking at where we want to follow approaches where we can fail fast, even if it doesn't work. We want to know earlier. So like I mentioned, a good enough solution it's need to be implementable. We don't want to shoot for perfection. So that's the idea behind it is, okay, let's prototype it. Let's build a version 1. So that's how I went about in my pharmaceutical example too. When I built that forecasting model, substitution model, using linear regression, I prototyped with a certain pilot group of products before implementing on large scale. Next slide. Yeah, so the 5th step is basically iterating through different sets of versions, and then again going back to empathizing it, defining it, ideating it, testing it, and iterating it. So, it goes on few iterations before you finally land up, okay, this is what it works in the industry. Next slide. Yeah, so the idea here is we want to find a sweet spot where this is the wow zone, where there is a good understanding of what the customer wants, what we can do with the capabilities of the tools and techniques, and the project's benefits and efforts. Is it worth doing? This is applicable even in the research world too, but it's more on the project's benefits and effort. There is more emphasis in the business world where they are very mindful of how much time and money you're going to spend on this project versus the other project. So it really helps in prioritizing, which we'll talk in the next slide. Yeah, so there was, you might ask a question whether design thinking process is applicable for any problem. So I am not familiar with the research side of things, but as far as on the industry side, I can tell most of the problems are people-centric. So if there is a people-centric problem, definitely you want to employ this design thinking methodology. And is there change management risk involved? Yes, obviously, you definitely need to use a design thinking methodology. Then is your data ready? How ambiguous your problem? I think in the research field, obviously you're navigating through a lot of ambiguous problems. So I think even in that, it actually can help you to refine your problems. So next slide. Yeah, so this is the earlier topic I was saying. When we are able to find that sweet spot, we are able to prioritize our ideas, which direction we should go. As researchers as well, you can understand what direction you want to steer your research towards, the earlier you understand those constraints. So in this case, I was able to work on idea 7 because it's a no-brainer and quick wins. And these kind of visibility we get only when we go through the working design thinking process. Next slide. So I want to conclude by saying data is the new oil, and that's what all the focus has been. So looking back 12 years ago, I read that article that says data science is the sexiest job of 21st century, and looking at today, it really happened actually 12 years, and I've been in the industry, and it has become more competitive. A lot and more people have come, a lot of great research. Even generative AI has revolutionized it, but how are we interpreting it? Is the risk, utility, and value plays a big role to make that impact come true in the industry. Next slide. Yeah, this is just a few of the slides that I added just to go through that example. Keep going, next slide. This is a pharmaceutical use case. Again, I want to talk about why design thinking was helpful. Here, I have followed it. I just want to highlight design thinking as a process and also tools. One of the tools is this one. We want to define the project scope. It's typically just doing an ethnographic research because it comes from the root of ethnographics or anthropology. Personally, before my graduate school, I actually went to school for anthropology. So I can relate to how important is ethnographic research in data science field. I didn't realize that at that time, but when I look at the real world problems in the business, that's when I realized. Keep going. So design thinking in a nutshell has the process as well as the tools. And I'm talking about these tools. The process is the 5-step process, but the tools as such is this things like journey mapping, next slide, mind mapping, and value chain analysis. Keep going, next slide. So these are certain tools within design thinking. So again, after using design thinking, I was able to find, during COVID, obviously there was an issue where when people were in panic, they wanted to order more, give me more for next 6 months. So I was in the pharma industry where there were a lot of supply disruption. We were not getting supply. Customers were ordering for next 6 months. So when I was given the problem of supply disruption, I was like jumping into the ocean of problems where I should start. But before design thinking, I was so confused. When I started using design thinking tools, value chain, and journey mapping, then I understood, okay, what are the things I can do? And I prioritize only these top 3 problems, identifying substitutable products, defining start date and data quality inventory, and then quantity. So this is how it can help in defining the problem. Keep going it. Yeah, this is another example in influence manufacturing where how can we find a better forecast and allocation methodology to solving chemical that is unconstrained. Next slide. And in this case, I mentioned about business translation. Next slide. Next slide. Yeah, so here I mentioned about how a business question is translated to a technical story, and that eventually becomes a work to do for as a data scientist person. How can they innovate these business problems to technology problem? Next slide. And next slide. I think we already talked about idea generation. These are one of the examples. And this is finally after idea generation, I was able to find, okay, these are the 3 problems we are going to work on. Next slide. So again, I want to conclude by saying data may be the new oil, but in its crude form, it becomes less valuable. But if you are using a more human-centered design thinking approach, can actually bring more value out of it. Next slide. The next questions time. If anybody has questions, I'm happy to answer. Or any comments, you're feel free to send them my way out.
Okay, thank you, Mr. Raj Mahalingam from Intel Data Scientist. Ladies and gentlemen, esteemed participants, we have just had the privilege of listening to an insightful keynote presentation by Raj Mahalingam, where he introduced us to design thinking, a human-centered approach to data science and information system. His expertise is in combining design thinking with data science has given us a valuable perspective on how human-centered methodologies can enhance AI-driven decision-making, optimize supply chain process, and create impactful business solutions. Okay, now we will move on to our discussion and Q&A session, where you have the opportunity to directly engage with Mr. Raj Mahalingam. This is a great chance to ask questions, gain deeper insight, and explore real-world application of design thinking in AI, supply chain management, and data analytics. Let's begin to the discussion. Who would like to ask the first question? Maybe from the online participant can ask the question to Mr. Raj by raise your hand virtual, or you can chat the question in the chat column in our Zoom. Okay, Who will the first question to Mr. Raj Mahalingam? Okay, Mr. Raj. Mr. Sinu,
Yes.
have question?
Okay. Mine is Sinu. I have seen your presentation, and I think it's good to see the data science in with design thinking. But maybe you can give some opinion or give some some information. But in my mind, that the data is maybe is very strict for maybe for mathematical or maybe for they have sure for precise thinking, and then design thinking is for creative people. So how we can do it between two like that, between mathematics and also with creative thinking in design thinking. So maybe this is my opinion. So maybe if I'm wrong, you can give any answer about it.
Yeah, can you repeat that question, please?
Sure. I think design thinking is, in my opinion, need more creative thinking and need more user interactive thinking. And but in data science is just maybe need more algorithm and mathematical understanding, and I would know how to mix it between the competence of data science and design thinking to make it better for maybe for the data scientists. Okay.
Yeah. That's a great question. Can you hear me okay? Yeah, so I think design thinking for a data scientist perspective is to make it more manageable for the ideas that comes from them. So, for example, when I started in the field of data science in 2012, there was a lot of misconceptions around how data science can help businesses. So at that time, there is a lot of hype. Okay, wow, this is data science, and the senior leaderships were getting a lot of pressure on how to implement these great research coming out and how they want to utilize this in the business world. So in the sense of understanding the research, they were missing out on what is the right problem to solve. So they have a greatest problem on hand, but they are using the wrong approach to solve it. They are using the wrong tools and things like that. So, so to answer your question, I think design thinking really helps to move away from numbers and how these numbers are impacting to people, and how it can actually help in enhancing the usability of those tools and techniques that is coming out of the research. So adding on to the world of research or academia, people in academia are also able to relate not just on the mathematical side and how people are interacting with their research, how they can better tell stories. So last week I attended a workshop on research storytelling. So storytelling plays a big role even in research. So having a design thinking approach really helps them to better tell the story of their research. I heard from my peers that introduction of a research paper plays a big role. If their story of introduction doesn't play well, it's going to affect the rest of the paper, how better it can be. So yeah, so I think it can play a big role both in the world of academics and industry.
Okay, thanks for the answer, Mr. Ranch. Next, we have the question from the Zoom chat. the question from Zainal Abedi. Maybe you can see
Yeah,
the
I can see the
chat.
question. Yeah.
Okay, the question is this design thinking running concurrently with business understanding or design thinking firstly? Okay.
Yeah, so great question. Business understanding is part of design thinking. Knowing that domain, knowing the business really plays well for your benefit, but design thinking is independent of whatever the business problem you're working on. So I started in data science in insurance industry. Then I moved on to pharma supply chain. Then I am in semiconductor supply chain. So for me, when I use design thinking, it is a process and a tool sets. So when I switched industries, it doesn't change. The process remains the same, the tools remains the same. But will I be a better design thinker if I know the business? Yes. If you know the business, you're able to empathize better. So going back to the point number one on process number one, in design thinking is empathy. So better you know business, the better you're empathizing. So that's how it is working. So first, you need to know about design thinking, whether you are in insurance, retail, supply chain, doesn't matter. So you can, if you know this 5-step process, you're going to be successful wherever you are. But your success increases, the better you know business as well.
Okay, thanks, Mr. Reds, for the answer. We still have a time for a few more questions. Please feel free to share your thought or your inquiries, maybe any other question from the participant. We still have 2 minutes left for the session. Okay, if there is no question for the participant, maybe I have the last question, Mr. Raj. As AI system become more complex, how can design thinking help us to ensure that AI solution remain ethical, transparent, and aligned with human needs? What advice would you give to business looking to integrate design thinking into their data science and AI strategies? I think this is my question.
So your question is what strategy business can use to implement design thinking to their processes, data science teams, right. So I think I would like to start with training. So a lot of companies has implemented training programs for their data science employees or research scientists. Even someone coming out of a research field, they are trying to move to industry. They are lacking the skill of business acumen. So I think leaders can start with training design thinking. So usually I also conduct design thinking workshops, which takes from 1 to 2 hours. It goes through practical example of designing an ideal wallet or designing an ideal pencil and an ideal cell phone, how it should be designed. So it takes like simple problems like this. It doesn't go into rocket science of what actually is a business problem. Then it trains people. So then also understanding use cases and success stories of using design thinking in data science. So I'm actually written articles and writing a book on it. So understanding how it has been used is really helpful. So starting with training and also starts with something smaller, that really would help the leaders to gain momentum on design thinking.
Okay, thank you, Mr. Raj, for your answer, and thank you to all participants for your provocative questions and engaging discussion. A special application goes to Mr. Raj Mahalingam for sharing his expertise on the intersection of design thinking, AI, and data science. His insight will certainly inspire us to rethink how we approach problem solving in data-driven industry. We now move forward to our next session. Once again, let's give a big round of applause to Raj Mahalingam for Intel. Thank you for your presentation. Now, we will going to a photo session. Please to our participant to open the cam and show your face. Okay, please, all participants to turn on your camera, and we will make a photo together. Okay. We still waiting for the participant to open your camera. Okay, please still more participant close the still the camera still off. Please turn on your camera, your webcam. Okay, we hope all participants turn on to your camera so we can see your face. Okay. Okay, please to the operator. Maybe the keynote before can also turn on the camera. Okay, we will start the screen capture for this session. To the moderator, I will give some comment. First, for the first screen, 1, 2, 3. Okay, please give your smile, the smile to us. Okay, 1, 2, 3. Okay. Okay. Thank you for all participants. Ladies and gentlemen, distinguished guests and esteemed participants, as we come to the conclusion of the first day of the 2025 ICADEIS conference, I would like to take a moment to reflect on the insightful and thought-provoking discussion we have today. We have had the privilege of learning from some of the biggest minds in data science, information system, AI, and digital transformation. And their expertise has truly enriched our understanding of how emerging technologies are shaping the future. Let's take a brief look at the key takeaway from our last three keynote session today. From Dr. Muhammad Arfian bin Ismail from UMPSA Malaysia, provide a deep dive into meta-heuristic algorithms, which are revolutionizing problem solving in optimization and decision making across various industries. He explained how evolutionary algorithms, swarm intelligence, and hybrid approaches are enabling industry such as engineering, healthcare, finance, and logistics to tackle complex challenges. His presentation emphasized the importance of balancing exploration and exploitation in such algorithm, ensuring that optimization solutions are both effective and scalable. His insight help us better understand the future of AI-driven optimization and how business and researchers can leverage meta-heuristic technique to improve efficiency and decision making. From fourth keynote speech, Mr. Daniel from Tecme Engineering. From Mr. Daniel, highlight one of the most pressing challenges in the healthcare industry, the lack of common standard protocol for asset management in medical institution. It's the big problem, especially in our country like Indonesia. He explained how the absence of standard integration among medical devices result in high costs and inefficient and delay response to equipment failures. He proposed the need for regulatory framework to enforce a universal plug-and-play integration model similar to protocol used in IT and telecommunication. His session also explored how AI, IoT, and data-driven analytics can enable proactive asset monitoring and predictive maintenance, ultimately improving healthcare efficiency and patient outcome. And the last from keynote speech, Raj Mahalingam from Intel Data Science. He introduced us to design thinking, a methodology that bridge the gap between business challenges and technical AI solution. He emphasized the importance of human-centered problem solving in AI, data science, and supply chain optimization, showcasing real-world application in pharmaceutical distribution and semiconductor demand forecasting. Key takeaway from his presentation include the importance of customer empathy in AI development, how rapid prototyping and iterative design enhance AI adoption, and the role of storytelling and visualization in making data science more impactful. His session reinforced the idea data science is not just about algorithm and models, but also about understanding human behavior and business need to create truly effective solutions. As we know of the session, as we wrap up today's session, I would like to express my deepest gratitude to all of our keynote speaker for sharing their expertise, insight, and research with us. Please give warm applause for the keynote today. Thank you. And their contribution have given us valuable knowledge and fresh perspective that will undoubtedly inspire further discussion and innovation in the field of data science, AI, and information system. I also want to extend my heartfelt appreciation to our participants. Your engagement, thoughtful question, and active participation have made today discussion incredibly enriching. Lastly, I would like to thank to the organizing committee, sponsor, and technical team who have worked tirelessly behind the scene to ensure the smooth execution of today's session. Tomorrow, we will continue with another exciting day of panel discussion and interactive session where we will explore more groundbreaking ideas and innovative solutions in the field of AI, data science, and learning technology. Until then, I encourage you all to connect, network, and share ideas with fellow researchers, industry professionals, and experts. Thank you once again for being part of ICADEIS 2025. We're looking forward to seeing you tomorrow. Thank you very much for today. Assalamualaikum warahmatullahi wabarakatuh.
Recording stopped.